Hi, hello everyone. Can someone confirm whether I'm audible?
Yes, sir.
Thank you. So yeah, currently there are like four four of us here. So maybe we can wait for like some 2 minutes. Maybe we'll start in like 2 3 minutes. So I think around 10 people are here. Maybe shall we start?
Yes, sir.
Okay, thanks. So hi everyone. Good evening. My name is Prasho. I am currently doing PhD in IAC Bangalore. So every Wednesdays during this time, 7 to 8, we'll be discussing gate solutions on signals and systems, communications, and some topics in Max. So today we'll be discussing questions on discrete type Fourier transform and discrete Fourier transform. This is more or less like a continuation of what we discussed last week. So let's checking the start by revising the basics. So consider a discrete time signal x of n. Then the discrete time Fourier transform of that signal x of n, small s of n, is defined like this: x omega, which is summation over n from minus infinity to infinity, x of n e raised to minus j omega n. Here, this omega is continuous and n is the discrete time index. Omega is the frequency. So, in this case, for DTFT, we call omega as the digital frequency. That's just the name that we use. Now, it turns out that this DFT is also, sorry, turns out that DTFT is also periodic with a period of 2 pi. Now, here we have the expression for DTFT. Similarly, given the signal x omega, given the DTFT, we can go back to the time domain signal x of n using the inverse DTFT expression, which is an integration that we have over here. Similarly, for a discrete time signal x of n, we can also define what is known as a n-point discrete Fourier transform or DFT. So how do we have that? So DFT is defined like this: x of k, which is defined like summation n equal to 0 to n minus 1, x of n e raised to minus j 2 pi by n kn. So if you see the expression for DTFT and DFT, they are very much similar, except for the fact that for DTFT, this omega is continuous, Whereas for DFT, we will be sampling this omega at 2 pi by n k, these values. That is how we are getting DFT from DTFT. So, in other words, DFT is obtained by sampling the DTFT at omega equal to 2 pi by n k for k equal to 0, 1 up to n minus 1, like that. So again, just like we have the inverse DTFT, we also have the inverse DFT. So given x of k, we can go back to x of n by using this inverse DFT expression that we have over here. So far these topics that we have been discussing in last week and also in some of the previous weeks. So before moving to the questions, I don't plan to spend more time on revising this because already we have discussed the same thing last 2 3 weeks. So maybe we can directly get to questions. So before that, is there any questions or any clarifications needed? Any doubts or anything? Shall we proceed to the problem solving part?
Yes, sir.
Okay. Thanks. So let us begin by discussing this question. So this question appeared in EC 2019 GATE exam. So the question is like this: it is desired to find a three-tap causal filter which gives zero signal as an output to an input of the form x of n, which is given by c1 e raised to minus j pi by 2 n plus c2 e raised to j pi by 2 n, where the c1 and c2 are some arbitrary constants. And yeah, now it is given that the desired three-tap filter coefficient, it is given like this. We have h of 0 to be 1, h of 1 to be a, h of 2 to be b, and then h of n is 0 for n less than 0 and n more than 2. It is asked that what are these values of a and b. So what are the values of the filter types a and b if the output of the filter yn is always 0 for all n whenever the input xn is of the form given here. So is the question fine? So basically here we are given a system, a three tap FIR filter to be specific, which are having the coefficients Hn, which is given like this. Now we have h of n to be 1, a and b. These are the coefficients. Now here this location 1 correspond to the time index n equal to 0. That is also given in the question. For other values of n, that is for n less than 0 and n more than 2, filter types are 0. That is also given. So the question here is that how do we choose these values of a and b so that yn is 0 whenever xn is given like this? It's not that yn is always 0 for any input. Whenever the input x of n is of this form, we need to have yn to be 0. For that to happen, what should be the filter types? That's a question. So, is the question fine or any doubts in the question? Any doubt or any clarifications? Shall we proceed? Okay, thanks. So, we will see some useful facts to be. I'm still audible, right? Okay. So, some useful facts. Now, we have a LTE system. It's given the question. So, if the input is x of n and the impulse response is h of n, then the output y of n is given by x of n convolution h of n. This we know. Now, the same relation between input and output can be written in the Fourier domain. How do we write that? We have convolution becoming multiplication. What exactly is it? Y of omega is given by h of omega times x of omega. This is the standard result that we have. Now, next one is how does the Fourier transform of exponential functions looks like? So we have a signal c1 e raised to j omega naught n. This will be having the Fourier transform 2 pi times c1 delta of omega minus omega 0 with the understanding So this, even though I'm not writing explicitly, but this is periodic. That means not just omega naught, but anything plus minus 2 pi times k. So that is also there. So to not to complicate notations further, we will just write it like this. So for a complex exponential signal having the frequency omega naught, the DTFT will be impulse function at that frequency. That's the way we can see this. So this will look like this. We'll be having at omega naught, there will be an impulse having strength 2 pi c1. Now, there are other peaks at omega naught plus 2 pi, omega naught plus 4 pi, and so on. But that is understandable. I mean, that we make that assumption. We already know that DTFT is periodic, so we won't be writing those things. We'll be just focusing on minus pi to pi. Okay. So, what do we have here? We have y of omega to be h of omega times x of omega. Now, what is our input signal? Our input signal is given by sum of two complex exponentials. One at omega equal to minus pi by 2, other at omega equal to pi by 2. So, what is the Fourier transform of input x omega is given by c1, okay, 2 pi c1 del omega minus pi by 2 plus 2 pi c1 del omega plus pi by 2. Basically, I substitute omega not equal to plus minus pi by 2. Why do we have that? Because this is of the form e raised j omega not n, and our signal is e raised to minus j pi by 2n and e raised to plus j pi by 2n. This is fine, no? So what do we have here? We have y of omega to be h of omega times 2 pi c1 del omega minus pi by 2 plus 2 pi c2, this is c2 del omega plus pi by 2. c1 and c2 might be flipped. Let me see. Okay, for minus pi by 2 it is c1. That means this should be c2 and this should be c1. It doesn't really matter, but yeah, for the sake of correctness we'll be writing it like this. Anyway, constant doesn't matter, and it will be clear in a while. Okay, now if we see this expression, this output y of omega will be non-zero only for two values of omega. So y of omega is non-zero only for omega equal to plus or minus pi by 2, because for the remaining values the input doesn't have any component, so the multiplication will be 0, because this term will be non-zero. This will be non-zero when omega equal to pi by 2, and this will be non-zero when omega equal to minus pi by 2. So it doesn't matter what is here, as long as these two are the input frequencies. We only need to worry about the output by omega at omega equal to plus or minus pi by 2. Now, what is the question? We need to find the filter types A and B, so that output yn is 0 for all n for this kind of input. So what does it mean? X omega is given, it is of this form. Now I need to choose the filter coefficients such a way that this product, this entire product is always 0. That is clear, right? So once again, so what do we have? We have product of two terms. This second term will be non-zero only for minus pi by 2 and pi by 2. And this term we want to decide. So what is the constraint? We need to choose this h omega or h of n so that y of n is 0 for all values of n whenever input is of this form. So what does this mean? This implies that we need to recall that h of n is given by like this: a b such that two things. h of omega equal to pi by 2, this should be 0. H of omega equal to minus pi by 2, this should also be 0. This is how we should choose the coefficients a and b. So is this clear? Like, is this constraint clear? How are we getting this? Shall we proceed? Up to here it's okay, no? Shall I proceed? Okay, thanks. So what do we have? We have h of n to be 1a and b. That means h of omega will be summation n equal to minus infinity h of n e raised to minus j omega n. This is given by 1 plus a e raised to minus j omega plus b e raised to minus 2j omega. We need to have these two things satisfied. So 1 implies h of pi by 2 should be 0, which implies 1 plus a e raised to minus j pi by 2 plus b e raised to minus j pi. This should be 0. Similarly, we have the sorry, the other equation here. From here, we need to have h of minus pi by 2 to be also 0. So what does this mean? This means we have 1 plus a e raised to j pi by 2 plus b e raised to j pi. This should also be 0. Now, if we recollect, e raised to j theta is nothing but cos theta plus j sin theta. So, what do we have here? We have this equation number 1. This means that a e raised to minus j pi by 2. This term is nothing but cos pi by 2 minus j sin pi by 2. Okay, that's better. 1 implies 1 plus e raised to minus j pi by 2 is cos pi by 2 minus j sin pi by 2. That means it is minus a plus we have the second here e raised to minus j pi. So e raised to minus j pi is cos pi, which is yeah, minus 1. We don't have any other. Sin term will be always 0. So that is fine. So this is the first equation. Second equation means, again substituting here, e power j pi by 2 will be cos pi by 2 plus j sin pi by 2. That will be just yeah, the second term will be there. I missed a j here. This should be j, but it's okay. Yeah. So I have 1 plus a j, that is the thing, and then e raised to j pi, that's again minus 1 minus b. This is 0. So if we add these two things, we can see that 2 minus 2b is 0, or b equal to, sorry, b equal to 1. Equal to 1. Now, once we have it over here, if we substitute b equal to 1 here, 1 minus aj plus, sorry, uh, 1 minus aj minus b, 0, and b equal to 1. That means minus aj should be 0, which means a equal to 0. So what it means, the value of these filter coefficients a and b should be these two values, a equal to 0 and b equal to 1. That means the solution is option D. Yeah. So any doubts or clarifications here? Is this okay? Shall we move to the next question? Okay, thanks. So next question, this appeared in 2017 GATE EC paper. So this question is like this. Let h of n be the impulse response of a discrete time LTI filter. Now, the impulse response is given by h of 0, which is same as h of 1, which is same as h of 2, which is 1 by 3. and h of n is 0 for negative values as well as n more than 2. So it's a three type filter basically. Now, sorry, h omega be the DTFT of h of n, where omega is the normalized angular frequency in radians. Given that h of omega naught equal to 0 and 0 less than omega naught less than pi, what is the value of omega naught in radians? That's a question. So this is kind of related to what we did before. The previous question, what we were doing is we were asked to choose the sorry coefficients a and b so that the output y of n is always 0. Now for this question, the response is already given, like h of 0, h of 1, h of 2, impulse response already given. We need to find what is the value of omega 0, for which we have h omega not equal to 0. That's idea. So any doubts in the questions? In this question, any doubt? I think it's okay. So what do we have? We have h of n equal to 1 by 3 for n equal to 0, 1, 2 and 0 otherwise. So we have the impulse response like this. We have h of n and n we have 1 by 3 for these three values and it's 0 everywhere else. Now it is also given that h of omega naught is 0 for some omega naught. So what is h of omega? H of omega is the DTFT, which is summation minus infinity infinity h of n e raised to minus j omega n. By the way, so in this question, this omega is given like this. In some textbooks and some places, will be this kind of omega is also used. So that's just a notation. Doesn't really matter much. We can either use this or we can use this. Doesn't matter. So in this question, since it is given this omega, I'm just using this omega. In the previous question, I was using the other omega like this one. They are same thing. I mean, it's kind of fine. Okay, so where are we? Yeah, this will be 1 by 3 times 1 plus e raised to minus j omega plus e raised to minus 2j omega. This is the DTFT of the given system's impulse response. Now is given that h of omega naught, this is 0 for some 0 less than omega naught less than pi. What is omega naught? That's a question. So what do we have here? We have h of omega to be 1 upon 3, 1 plus e power minus j omega plus e power minus 2j omega. We can substitute omega equal to, we get h of omega naught, which is 1 by 3, 1 plus e raised to minus j omega naught plus e raised to minus 2j omega naught. This is 0. Is given the question. What it means, 1 plus e raised to minus j omega naught plus e raised to minus 2j omega naught. This is 0. We need to find what is omega naught. So how do we do this? This is not a linear equation, so there is no the usual way to take one to the left, one to the right and all that we can't do here. This is not a linear equation. So how do we solve it? We can solve it like this. Take e raised to minus j omega naught common. So we can write like e raised to minus j omega naught. This will be, there will be 1 here. So this is e raised to plus j omega naught. Now this second term e raised to minus j omega, this will be 1 itself. And this term will be e raised to minus j omega naught. So this is 0. Or in other words, e raised to minus j omega naught 1 plus e raised to j omega naught e raised to minus j omega naught. This is 0. Now we have product of two terms, this term and this term. Now if you see this term cannot be 0. This is a unit modulus quantity. This cannot be 0. So this term So for any omega in 0 to pi, this first term, this cannot be 0. Is that clear for everyone? Is that fine? Shall we proceed further?
Hello,
Hello?
sir.
Yeah.
Sir, how do we know that it is not a linear equation?
No, linear equation in the sense that if I have something like a plus b equal to 1, that is linear. So I don't know what is a and b, these are the unknowns. So this is linear in the unknowns. But here it's exponential, right? So the unknown is on the, it's a, it's an exponential function of the unknown. Omega naught is my unknown. So if I have like what y equal to e raised to x, this is a exponential function. This is not a linear function. That's it. So, or in other words, this is not a equation of a straight line. So,
Okay, sir. Okay, sir.
yeah, that was not very important. I just told it in the flow. But what I wanted to say is that we can't directly use something of this stuff here because the unknown is on the exponent. So we need to kind of write in a different way. So for that, in this case, we just pull this term out and yeah, we just wrote it like this. Now, the main point here is that we have a product of two terms, out of which this term cannot be 0. That is fine, no? This term cannot be 0 for any omega in 0 to pi. That's okay, right?
Yes, sir.
Okay. So, what does that mean? This implies that 1 plus e raised to j omega naught plus e raised to minus j omega naught. This is 0. Now, we can use one result. So, what is cos omega naught? This is e raised to j omega. This is e raised to j omega naught plus e raised to minus j omega naught by 2. Now, using this, what we have is 1 plus 2 cos omega naught is 0 or cos omega naught equal to minus half. Now, omega naught is in the range 0 to pi. So, what is minus half? Cos omega naught is minus half means omega naught equal to 120 degrees. That is equal to 2 pi by 3. So, yeah, this is okay, no? So, the question answer is 2 pi by 3. Is that okay? Shall we proceed to next question? Okay, thanks. Now, this question appeared in 2018 JTC paper. So, this is slightly different from the previous ones. So, this is on DFT by the way. So, question is like this. Let x of k equal to k plus 1 for 0 less than k less than equal to 7 be the 8-point DFT of some sequence x of n. We don't know what it is, not given. So here they have also given how do we define the DFT. You have x of k to be summation n equal to 0 to n minus 1, x of n e raised to minus j 2 pi by n k, the usual definition. Now, question is like this. What is the value of this quantity, this summation n equal to 0 to 3, x of 2n, correct up to 2 decimal places? So unlike the past two questions, we are not asked to find the impulse response or any of those things. It's given that DFT of a sequence is given by x of k equal to k plus 1. And we don't know what is the sequence. Given this information, we need to find what is the value of this summation. That's it. So, is the question fine? You can move to the solution, no? Yeah, I think it is okay. Okay, so what? How do we have the DFT? This is how it is given. So x of k is nothing but summation over n x of n e raised to minus j 2 pi by n k. So I can write like this. In our case, n equal to 8. It's given in the question. It's a 8-point DFT. So what do we have? I have x of k. This is the DFT. This is given by summation n equal to 0 to 7 x of n e raised to minus j 2 pi by n kn where n equal to 8 here. Now this summation I can write into two parts. I can take all the odd terms and even terms separately. So what do we have? N equal to 0 to 7. I can write like summation n in 0 to 4, 6 something plus the remaining terms n in 1, 3, 5, 7 Am I audible? Okay, I think yeah. Actually, my net code disconnected. Let me connect back. The screen is now visible now.
Yes, sir.
Okay, thanks. So where were we? Yeah, we rewritten this summation into two parts. One for the even terms, other for the odd terms. Now these two terms we can write like this. This even terms I can write like n equal to 0 to 3 x of 2n e raised to minus a 2 pi by n k 2n. So I just this I wrote like this. Basically the sum of even terms I can write like this. Similarly, we have the sum of odd terms here, and that I wrote like this. N equals 0 to 3, x of 2n plus 1 times e raised to minus a 2 pi by n k times 2n plus 1. This is fine, no? This is kind of the usual technique that we use. Okay, right? By the way, if there is any doubt at any point of time, please feel free to interrupt. So what do we have? X of k is given by summation n equal to 0 to 3, x of 2n something plus this term over here. What is the question we need to find is this quantity. This is what we need to find. Okay. So it is also given that x of k is k plus 1. Now from this equation and this fact, we need to find what is summation 0 to 3 x of 2n. So how do we do that? So we can substitute certain values of k here. So what happens if we put k equal to 0? If I put k equal to 0, I'll be getting x of 0, which is summation n equal to 0 to 3 x of 2n plus summation n equal to 0 to 3 x of 2n plus 1. So why did I keep k equal to 0? That is to kind of get these two expressions. This is what I want. This is something that came up when I substitute k equal to 0. I only want what is the value of this thing. This I don't want. So for x of 0, what is the value of x of 0? This will be k plus 1, which will be 1 in this case. It's given in the question that x of k is k plus 1. So what do we have here? We have x of 0, which is 1, which is given by summation over n x of 2n and summation over n x of 2n plus 1. Now, what I want? I want the value of this term. So for that, what I can do is I can choose a value of k so that this first term is same, but second term has a negative. So what I'm telling is, if I choose k equal to 4, let us say I choose k equal to 4, then this 2 pi by n k, this term, that will be pi. What it means is that x of 4 is given by summation over n 0 to 3 x of 2n e raised to minus j 2 pi n plus summation over n 0 to 3 x of 2n plus 1 e raised to minus j 2n plus 1 pi. This is how it will come. Now, what is this? E raised to minus j 2 pi n. This is always 1 for all values of n. Because this is like cos 2 pi n plus j sin 2 pi n. That is always 1. Similarly, this second term, this is cos 2n plus 1 pi minus j sin 2n plus 1 pi. And for this sine, it is always 0. And for cos, it is cos of an odd multiple of pi. That is minus 1. This is okay, right? You're following, right? If there is any doubt, please ask me. So what do we have? We have x of 4 to be summation n equal to 0 to 3 x of 2n minus summation n equal to 0 to 3 x of 2n plus 1. Now we see these equations, equation 1 and equation 2. What do we have in common? We have this term same, and this term is having opposite signs. So we can just add them like 1 plus 2, equation 1 plus 2. What do we have? We have x of 0 plus x of 4 from this. That is same as 2 times this term. This is okay, right? I have x of 0 plus x of 4, which is given by 2 times summation n equal to 0 to 3 x of 2n. What I want is, I need to find what is the value of this term. So what do we have? N equal to 0 to 3 x of 2n. This is given by x of 0 plus x of 4 by 2. Now for this question, it is given that x of k equal to k plus 1. So what do we have here? X of 0 is 1, x of 4 is 5. That means this summation is 3. So the correct answer to this question, this is 3. So any doubts here? Is everything okay? Shall we proceed further?
Yes, sir.
Okay, thanks. Okay, so next question. This is kind of related to the first question, but somewhat different. So what it is, it's like this. Consider a 4-point moving average filter defined by the equation y of n, which is summation I equal to 0 to 3 alpha I x of n minus I. The condition on the filter coefficients that results in a null at 0 frequency is which of this? So basically the question is like this. We have a 4-point moving average filter. So what does that mean? We have the output y of n is given by summation I equal to 0 to 3 alpha I x of n minus I, or this is same as the usual convolution I equal to 0 to 3 h of I x of n minus I, or the h of n convolution x of n, where h of n is given by alpha 1, alpha 2, alpha 0, alpha 1, alpha 2, alpha 3. That's it. So we have a this 4-point moving average filter, that is a linear time invariant system. This is the input output relation given in the question. So we can just write it like this. Y of n is summation I equal to 0 to 3 alpha I x of n minus I. That means something like this. Now, what is the question? We want a null at 0 frequency. So what do you mean by null? So what it means is that consider the frequency response h omega for some filter. It can be some shape. Now, there will be certain places in the response where this omega naught will be exactly 0. So wherever we have the frequency response to be exactly 0, those points are known as null frequencies. So this thing is the null frequency. Sorry. In this question, what is given is that we need to find what are the condition on this alphas so that we have a null at zero frequency. It's kind of confusing, this null, zero, everything. So the thing is simple. We have a function h omega which is 0 at omega equal to 0. That's it. So in a different way we can write like this. We have h of omega equal to 0 to be 0, and we need to find the coefficient values alpha 1, alpha 2, alpha 3, alpha 4 so that this will be satisfied. So question is clear, no? Any doubt? Shall we proceed? Okay. So what do we have? So this is how we can find the response. So we have no need to get carried away by this set transform. So it's given that this is how the input output is relation. Y of n equal to summation I equals 0 to 3 alpha I x of n minus I. Now, how do we find the frequency response h of omega? We can do it like this. Let us take the set transform of the signal. So x of n be the discrete signals, then set transform is this one. Now, we also know that if x of n is x of z, then x of n minus k will be having the set transform x of z raised to minus k. These are like the standard properties. We will be discussing more about this in the next week session, but these are fairly well-known properties. So how do we get the DTFT from the set transform? That is also easy. Evaluating the set transform at omega equal to at z equal to e power j omega, that will give you DTFT. This is fine, right? I'm going a bit fast because these are like we already discussed some time back. Any doubts here? Shall I proceed further?
Yes, sir.
Okay, thanks. So it's given that y of n is summation I equal to 0 to 3 alpha I x of n minus I. So the set transform will be something like this. By the way, even if you, I think no need to go that complicated. Even if you don't recollect what is a transform, this is kind of simple only. We know that h of n equal to alpha 0, alpha 1, alpha 2, alpha 3. This is given in the question. That means h of omega will be summation over n alpha n e raised to minus j omega n. That's it. Even if you, I just wrote the set transform so that we have that flow, but it's okay. I mean, since we know what is this h of n, we can directly compute. So what do we have? H of j omega, or the frequency response, is given by summation I equal to 0 to 3 alpha I e raised to minus j omega I. So this is clear now. How do we get this? I wrote it using set transform, but that much we don't need. I mean, we directly can compute like this. So what is the question? It is given that there is a null at 0 frequency, means at omega equal to 0. So what do we have? H of omega at omega equal to 0 is 0, or summation I equal to 0 to 3 alpha I e power minus j omega I at omega equal to 0. This is 0. In other words, this is the condition. That is okay, right? Alpha 0 plus alpha 1 plus alpha 2 plus alpha 3. That should be 0. So any doubt here? This is the condition on the coefficient so that the given system will be having a null at omega equal to 0. Is that okay?
Yes, sir.
Okay. So how do you pick the right option? If we see the options here, we need to choose the option so that there should be 0. That's the only condition. Now, if we see one by one, If we have alpha 1, alpha 2, 0, and alpha 0 is minus alpha 3, what do we have? We'll be having alpha 0, alpha 1, alpha 2, alpha 3 will be alpha 0, I'll write alpha 0, alpha 1, alpha 2 are 0, 0 plus 0, and alpha 3 is minus alpha naught. So what does mean? If we choose the coefficients like this, then this alpha naught plus alpha 1 plus alpha 2 plus alpha 3, this will be 0. That means the correct answer is option A. Is that fine? Any doubt? So what we did is not much complicated. It is in this question, it is given that this is how the input and output are related. Now this yn equal to this expression we can write like h of n convolution x of n, where h of n is given by alpha naught, alpha 1, alpha 2, and alpha 3. Once we know what is h of n, we can easily compute what is h of omega like this. We have h of omega like this. And in the question, it is given that the system is having a null at the zero frequency. And what does that mean? That means h of omega equal to 0 for omega equal to 0. And we also have the expression for h of omega. So we just substitute omega equal to 0. We just substitute omega equal to 0 in the expression for frequency response to get the condition on the filter coefficients. So we found out that we need to have alpha naught plus alpha 1 plus alpha 2 plus alpha 3 to be 0. In the question, there are four options. We need to pick the right option so that this condition is satisfied. It just happened to be the first question, but for the sake of completeness, if we see remaining, if alpha 1 and alpha 2 are 1, this will not be 0. Similarly, for it's easy to verify that for this case and this case also, we will not be having this thing to be 0. So, option A is the correct answer. Is that okay? Shall we move to the next question, or like is it too much content? We can solve one more question, I think. Am I going too fast? Generally, I won't be covering 4 questions in one class now. We still have 10, 15 minutes, 10 minutes at least left. So, shall we move to the next question, or if you have any other doubt in any of the questions so far, we can discuss. That's also fine. Next question. Okay, fine. Okay. So, this question appeared in 2015 JTC. So, what do we have here? It's like this. Two real sequences with yeah, two real sequences with origin indicated using underline is given like this: x1n, which is 1 2 3 0, and x2n, which is 1 3 2 1. Now this is the origin and this is the origin. So we have two sequences which are non-zero for positive values, I mean non-negative values. Now let x1k and x2k be 4-point DFTs of x1n and x2n respectively. Now another sequence x3n. X3n is derived by taking 4-point inverse DFT of this quantity. We take the product of x1 and x2, take an inverse DFT, then we will be getting x of 3. Sorry. So given all these things, what is the value of x3 of 2? So note that these are time domain signals, these are small x basically, and these are frequency domain, so these are capital X. So in the exam it will be more clear now that I written. This might be kind of confusing, but this is x of n, x1n, this is x2n, this is x1 of k, and this is x2 of k. It is given that x3 of k, this is related like this. We need to find what is the signal x3 of 2. So is the question fine? Any sorry. So any doubt in this question? Shall we move to the solution? Okay, thanks. So this is one useful property. So if we have x1 of n to be having the DFT x1k, x2n having DFT x2k, convolution of them x1 of n convolution x2 of n. By the way, this is circular convolution. X1n circular convolution x2n will be having the value x1k times x2k. This is the usual convolution property. Now, by the way, what is circular convolution? We can x1n circular convolution x2n. This is defined like this: summation over n 0 to n minus. Let me keep kn minus 1 or something else m x1 m x2 n minus m mod n. Now, this notation is what we use for circular shifting. And what does that mean? That means, for example, if we have a sequence 1, 2, 3, 4, this is basically the circular shifting. What do? We will do the normal shifting, but whichever is falling outside the range 0 to 3, we will be bringing it back. What do I mean is that here we have shift of 1. So 1 will come here, 2 will come here, 3 will come here, and 4 will go here. But since this is a circular convolution, this 4 will come back here. That means this is the circular convolution. So this is clear, no? Any doubts here? Shall we proceed? Okay, right? Okay. So what do we have? Given x3 of n, the time domain signal. How do we get that? This is inverse DFT of x1k, x2k. This is how we have the relation. Now, what is this? This is inverse DFT of of x1n circular convolution x2 of n. Is this clear for everyone? Is this okay? In the question, it is given that we get x3 of n by taking the inverse DFT of set of two sequence which themselves are DFT of some things. So this is given. These two sequence x1 and sorry x1 and x2 are given. Capital X1 and capital X2 are the 4-point DFTs of this and this respectively. Now we compute the X3 by finding the inverse DFT of this thing. So what do we have? X3 of n. This is time domain. This is inverse DFT of x1k times x2k. From the properties, we know that if x1n is giving x1k and x2n is giving x2k, then x1k times x2k correspond to the DFT of circular convolution of x1n and x2n. This we know from the property. This is not given in the question, but this is from the property. So what do we have? We have x3 of n to be IDFT of DFT of x1n circular convolution x2n. Or in other words, what is this? Whenever we have inverse DFT and DFT together, that means this DFT operation will get cancelled out each other. We have here we take a DFT, we take the inverse DFT, so we'll come back to time domain. So what do we have? X3n is X1n circular convolution X2 of n. Is this fine for everyone? Is any doubts here in this question till this point? Any doubt? Shall we proceed? Can continue now. Okay, thanks. Now, what is asked? We need to find what is x3 of 2. That's it. So, what do we have? x3 of n is given by summation m equal to 0 to 3 x1 of m x2 of n minus m circular shifted version like that. And we need to find what is x3 of 2. Okay. Now, what is x1 of n? This is given by 1230. What is x2 of n? 1321. What do we want? We want this term x2. I need to do a circular flip followed by circular shift. This is a flip sorry, and shifted version. So what do we have? I can first compute what is x2 of minus n, the circular reversal. That means this will be same, but then it got flipped. This is okay, no? This is fine for everyone, right? How did I do the circular flipping? This 1321, I'll just mirror it to this side. That's it. So 1321, this will be there, but 321 will come to other side. But this is again circular. So I'll just push the remaining things to the other side. That's it. So this is the circularly flipped or circularly reverse version. What do I want? I want x2 of 2 minus m. So I want to do a circular shift by 2 places to the right. What happens? This 1, 1, 2, 3. It will come like this. Okay, right? Okay. So what do I have? I have x3 2 to be summation m equal to 0 to 3 x1 m x2 2 minus m, and this we can write like this 1 2 3 0. This is x1 n, and x2 of 2 minus n, this is 2 3 1 1. I need to do a multiplication between these two things. What I have 2 plus 3 into 2 plus 1 into 3 plus 1 into 0. This is 2 plus 6 plus 3. This is 11. Is that okay? This is fine. Any doubt? Any questions or any doubt here? Okay. So what I want, this up to here it's clear, no? After this it is clear, right? Okay. So what I want, I just want to so evaluate this term. So how do I do that? I have x1m with x1n whatever, that I have it like this, and I want to find the, I want to multiply x1m with corresponding term of this signal and take the sum. So for that, what do I do? I'll be writing what is x1m like this given. Let us call this guy like let's say x2 hat. Yeah, let us call it x2 hat m. So what is x2 hat m? This is x of 2 minus m x2. Yeah, like this. Clear now? I'm just calling this using a different name. That's it. Now, how do I compute this quantity? I have my x2. I have my x2. This term here, this is a convolution, usual convolution. So what we do? We do a time flipping. We flip and then shift. That is how we do convolution, right? So for circular convolution, we'll be doing a circular flip or circular reversal followed by circular shifting. So for that, what I did, I have x2. I did a circular flip. I flip this like this. This is a circular flipping operation. This thing. This is clear. This is fine. Here to here. This is okay. Okay. Now, once I have this circularly flipped version, to evaluate this convolution, I need to shift it. Shift it by how much? Shift it by 2 units in our case. So what I have this circularly flipped version. I'll be shifting it right by 2 units. What happens? This one comes here, this one comes here, this 2 goes there, but it will come back because it is circular. And again 3 goes after 2, but again it will come back because it is circular. So this is how we do the circular shifting. That is also fine now. Is it okay? Okay. So now I have what is x1 and what is this x2 hat. I just want to find the corresponding products multiplication. So x1 is like this. The x2 hat is like this. And what I want? I just want summation over m, x1 of m, x2 hat of m. That's it. This is okay, right? I just want to find this. How do I do that? Multiply the corresponding terms and add them. Correct, no? Is that okay? Okay. So, is that clear now? Any other questions? This is okay now? Okay. Thanks. So, yeah, so any other questions? I think it's 8. So, any question or any clarifications still no? Like any doubts or any feedback? Am I going too fast? I don't know. This is the first time I am covering 5 questions in one class. I think in the last 6 months I am doing this for the first time. So I don't know. Did I go very fast or like? Unlike the usual sessions, I did not spend too much time on the background today. I didn't tell much theory, so maybe that is one of the reasons. But is this understandable? Like, is it, should I slow down or should I make any change in the way I present or any other feedback? Is this okay or should I continue like this or any suggestions? I think it's okay. This is okay, right? Okay. By performing convolution, we get the. No, convolution means it's circular convolution. That's it. Not the usual linear convolution. Okay. So, what was the other comment? This yellow means I didn't understand the other comment. Is it coincidence or is there any relation? Basis. Okay. Okay. Thanks. Thanks. Is it coincidence or is there any relation? Uh, what is coincidence? You're asking like which part actually? So this is the property actually. Like if we have the product of two sequence in the frequency domain, this is having the corresponding serial time domain like this. X1 in circular convolution x2n. This is how we have it. Now, yeah, this is always true. I mean, x1k times x2k will be giving x1 and circular convolution x2n. That's it. So this is circular convolution, not the linear convolution. That's the only thing. That's the property. So by performing linear convolution, you are getting same answer. Sure, eh? Let me see. No, I didn't try that actually. So what do we have here? By the way, for others, like I think I'm not trying to discuss anything new. So if you guys can, we can. That's also. Can you? Oh, okay. I'll come to your question. By performing linear convolution, I'm getting same answer. I didn't try that. If you're getting, then that's a coincidence. If you're getting, but I didn't verify whether that's the thing. I didn't check it, but if you're getting, that's just a coincidence. 1, 2, 3, 0, and x2. What is it? This is 1, 3, 2, 1. So x2 minus n will be 1, 3, 2, 1, and x2 of minus n plus 2, that will be, how do we have that? Sorry, yeah, 2 minus n. We're shifting it right. So we have 1, 3, 2, 1. No, this will be 2 plus 6 plus. Oh, yeah, nice. Yeah, this is just a coincidence. Yeah, just a coincidence. Is that okay? This is just a coincidence. It's not like always the case. Other question: do you have any Telegram group for doubt solving? Actually, no, we don't have. We don't have any Telegram group, and if you have any doubt, you can ask in the live session. And if there is any specific question, you can mail me also. But most of the times, like I'll be discussing in the live session. That will be better. So we don't have any group, and yeah. If there is any particular doubt on the questions that we discuss in the session, you can contact me. This is my mail ID. So yeah. And that means we have to use circular convolution for DFT. Correct, correct. So whenever we have DFT, we need to use circular convolution. You're right. And the other question, can you explain HFN in the previous question? So, by the way, did I answer your question? The other, okay, thanks. Okay, so it is given that we have a system like this. So what do we have? I have y of n summation I equal to 0 to 3 alpha I x of n minus I. This is same as writing summation over I h of I x of n minus I, right? If my h of n is given like this, these two are same, right?
Yes, sir.
Okay, so
Yes.
so since these two are same, I just wrote it in a more familiar form. That's it. So once I have this equation, this is what this is h of n convolution x of n. That's it. So remaining things will be just following from here. No, that is okay, right?
Yes, sir.
Okay. So any other questions? If it's okay, we can pause for the day. Any other
Thank you,
question?
sir.
Or sorry.
Thank you, sir.
Okay, okay, yeah. Okay. So maybe we can pause for the day. Any other questions?
Sir, I have sent you some questions.
I'll check. I'll check. Next
Oh,
week we will be discussing
Z transform.
set transform. Yes, yes. By the
Okay.
way, if anyone have any particular question to be discussed in the next class, that you can mail me. That is also fine. So I may not be able to do everything, but something I can try. So okay. So next week we will be discussing set transforms. Okay. Thank you very much. Thanks for attending. Some theory when needed, definitely. Yes, yes, yes. So this thing we already same topic we discussed last week, so that's why I just went a bit fast. But whenever I'm introducing anything new, I'll be definitely spending more time. Or even if I'm not explaining, if it is not clear, please ask me at that time, I will explain it at that time. So the point is to understand, not to solve more number of questions. So if we don't understand the theory, then solving more questions won't help actually. So if there is any doubt or any confusion at any time, please interrupt the class. Not a problem. So okay. Okay then, so next week we'll discuss set transforms. So thank you. Thanks for attending. Okay, I'm going to end the meeting. Okay. Okay then. Thank you.